Hi boys and girls, we sure have done a lot of learning about quadrilaterals this week, and we're going to add to it with some really deep thinking today about decomposing quadrilaterals to form triangles. We learned about decomposing last week, how you can decompose something, that means to break it apart or split it apart. Well, we're going to decompose quadrilaterals to form triangles, and then we can study that. So let's begin. Let's take a look at this parallelogram. We are going to make a diagonal line through the parallelogram. And what two shapes did we create when we did that? I took a line and I went from vertex W to vertex Y, and I got a diagonal line. We can name that diagonal line. What would we call that diagonal line? Do you remember how we labeled lines when we created them at the very beginning of this chapter? That is line WY. Now that I have that diagonal, I formed two triangles on either side of that diagonal. What are the letter names of those triangles? I see triangle WZY, and I see triangle WXY. So we could label our triangles using the letters WZY and WYX. Now we're going to look at it and say, what kind of triangles are they? All right, now we're going back to our triangles learning. You see how we're applying everything now that we've learned so far in this chapter to do some really great thinking today. What kind of triangles are those? We're looking to see if it's obtuse, acute, or right. So let's look at triangle WZY. W looks like it is an acute angle. At vertex Z, that's also an acute angle. And then at vertex Y, that's also an acute angle. Remember, every triangle has two acute angles, but it's that last angle that will tell us what type of triangle it is. Let's look on the other side of the diagonal. Let's look at YXW. Y is an acute angle at vertex Y. The acute angle is also at X, and there is an acute angle at W. So all three angles are acute. Therefore, both these triangles are acute triangles. So we've decomposed this parallelogram to form two triangles. We named the triangles, and we identified what type of triangle they are. Let's continue. What if I draw a diagonal from the other vertices? What if I draw a diagonal from Z to X? What would our line name be? Right, our line name would be ZX, line ZX. What are now the letter names of the triangles? They've changed too. I now see ZWX as a triangle, and I see ZYX as a triangle, and those can be in any order, so I named them triangle ZWX and triangle ZYX. Now, what kind of triangles are these ones? Well, at vertex Z, that's acute. At vertex X, that's also acute. But at vertex W, that's obtuse. So remember, every triangle has two acute angles. The third angle determines what it is. That third angle says obtuse. So I think that one is an obtuse triangle. Look on the other side of the diagonal. Look at triangle ZYX. Vertex Z has an acute angle in it. Vertex X has an acute angle in it. But that vertex Y has an obtuse angle in it. So it is also obtuse. So the types of triangles we have now are obtuse. When we drew the diagonal from W to Y, we formed acute triangles. When we decomposed the quadrilateral from Z to X, we got obtuse angles, or triangles. Let's keep going. Right from your student activity book. We're going to answer 4 questions on each of these pages. First question, what are all the names for that quadrilateral? What can you name it? It's definitely a square, so that's probably the first thing that popped into your head. That's definitely a square. Is it also a rectangle? A rectangle has to have 2 pairs of parallel sides and 4 right angles. So, yeah, that's a rectangle. Is it a parallelogram? A parallelogram has to have just 2 pairs of parallel sides. Then we can call it a parallelogram. So it's a parallelogram. Is it a rhombus? A rhombus states you have to have 2 pairs of parallel sides and 4 equal sides. We have that, so that's a rhombus. Is it a trapezoid? Trapezoid says it can only have 1 pair of parallel sides. So it is not a trapezoid. I think we can name it 4 different things. It's a square, it's a parallelogram, it's a rectangle, and it's a rhombus. We're going to call it a square for the sake of this page, okay? Because that's what we all recognize it as. Now, look at the diagonal I drew from vertex A to vertex C. So what would I call that line? I would call it line AC. That means I formed 2 triangles on either side of the diagonal. Can you name those triangles? I see triangle ADC, and I see triangle ABC. So it looks like I can name those triangles pretty easily. Now, what types of triangles are they? All right, triangle ADC. Well, A is an acute angle, C is an acute angle. Remember, we always have 2 acute angles in every triangle in the world. It's that 3rd angle that tells me what type of a triangle it is. At vertex D, that's a right. So we have a right triangle. What if I switch my diagonal from D to B and switch it over to that? My new line would be line DB. My new triangle names are DAB and DCB. So I have new names for triangles now. Now I have to tell me what type of triangles I have. It looks like I have, at D and B, I have acute angles. At vertex A, there's my right angle. If I look at the other triangle in that picture, D and B are still acute angles, but vertex C is a right angle. So again, I have a right triangle. So when I decompose a square, no matter which diagonal I put it, I end up with right triangles. Remember that. Let's try a tougher one. What shape is this? How many different names can you give it? It's not a square because it doesn't have right angles. So it can't be a rectangle either because it doesn't have right angles. So now my choices are parallelogram, rhombus, and trapezoid. Is it a parallelogram? 2 pairs of parallel sides. Yes. Is it a rhombus? 2 pairs of parallel sides and 4 equal sides. Ooh, yes, it's a rhombus. Is it a trapezoid? 1 pair of parallel sides. Nope, not a trapezoid. So there are 2 names for this one. It is a parallelogram and a rhombus. We're going to call it a parallelogram. I'm going to take the parallelogram and I'm going to draw a diagonal from vertex E to vertex G. So my line name will be EG, which gives me 2 triangles. My triangles are EHG and EFG. Now, what types of triangles are they? E is an acute angle. At vertex G, that's acute. At vertex H, that's acute. So that's an acute triangle. Does it match on the other side? E and G are acute, and F is also acute. So we have 2 acute triangles. Now, I'm going to take the parallelogram, and instead of drawing the diagonal from E to G, I'm going to draw the diagonal from H to F. So my line is now HF. My triangles are now called H-E-F. And my other triangle is called H-G-F. So I have two triangles with new names. What types of triangles are these? Ooh, look at vertex H. That's acute. Look at vertex F. That's acute. Remember, we're supposed to have two acute angles. It's that third one. Look at vertex E. That is an obtuse angle. I wonder if it's the same on the other side of the diagonal. Vertex H is acute, vertex F is acute, but vertex G is obtuse. So we have an obtuse triangle. So a parallelogram, if I decompose a parallelogram from one direction to another and then take the diagonal the other way, I get different types of triangles. I can get acute triangles, or I can get two obtuse triangles, depending on how I decompose that quadrilateral. Interesting learning. One more. Let's take a look at it. What are the names? What is that? Hopefully you said that's a rectangle. Sure is. Is it a square? Nope, can't be. It's not four equal sides. Is it a rhombus? Well, a rhombus has two pairs of parallel sides, but they have to be equal, so it's not a rhombus. Is it a parallelogram? Two pairs of parallel sides. Yes. Is it a trapezoid? Only one pair of parallel sides? No. So the names that we can give this quadrilateral are parallelogram and rectangle. So, what's the name of the diagonal line I drew through that parallelogram? The line I drew was from J to L, so that is line JL, which gave me two triangles on either side. Triangle JML and JKL. I have two triangles. What types of triangles do I have? Well, I've got two acute angles, one at J and one at L, but that angle at M is a right angle. So this is a right triangle. Let's see if that's the same now if we use our diagonal going the other direction. If we draw a diagonal from M to K, our line would be MK. Our triangle names would be MJK and MLK. What types of triangles are these? It looks like we have acute, acute. M and K are acute, but J is a right angle, so that's a right triangle. MLK, triangle MLK, M is acute, K is acute, but L is a right. So again, we have two right triangles. So for a rectangle, it doesn't matter which way we split it because we'll get right triangles because we have four right angles. So we have to get right triangles out of it. Makes sense, right? All right, here's what you're going to do today. It's your turn to practice. So you're going to get on Teams right now, and you're going to go to Assignments. I want you to click on Decomposing Quadrilaterals. You're going to open up that document. Now, you must click on Edit Document for you to be able to type your answers in the document. So, click on Edit Document. You'll have two choices, Edit in Browser or Edit in Microsoft App. I choose Edit in Browser because it just stays right there on that page. It's easier. You can just type your answers into that document right there. Okay, you don't have to go anywhere else. When you're done with all of your answers, when you're finished, click the Return word, and it'll come back to me for me to give you your grade for the day. So, it's Teams Assignments. Click on Decomposing Quadrilaterals. Open that document up. You have to click on Edit Document before you can begin typing your answers in the document. And then just click Return when you're finished. All right, boys and girls, get to work. Tomorrow we're going to do some tougher ones.